number C, and this one is ln e to the power of 3x is equal to 3. So again, we're going to use our basic factor of 2 to the power of 3 is 8. Log base 2 of 8 is 3. Ln is log e, log base e. So 3 to the power of 3x, no, e to the power of 3x is equal to e to the power of 3. So then now my bases are the same, so I can say 3x is 3, which makes x equal to 1. X is equal to 1. Remember again here, ln e are opposite operations. So ln e gives us a 1. Ln e gives us a 1. If you look now at number 4, now they are asking you now to draw a graph, and I would like you to draw number 4 now. There are actually 2 graphs that we are going to draw now there. So the first one, if you have this basic one of y is equal to e to the power of x, we're going cutting here at 0, 1. Then they want you e to the power of 2x, so it just looks a little bit more like that. And then e to the power of y is equal to e to the power of 3x. And the shape just changes a little bit. This is how that value will change your shape. And then we also have this negative one. So again, it will look like this. This is then y is equal to e to the power of negative x. And then again, they will grow a little bit steeper and a little bit steeper there. The last one being y is equal to e to the power of negative 3x. That's how the graph will change. That's how those graphs will change. Remember, the one's domain is the other one's range. So here, your domain is still x is an element of the real numbers. And here, the y values, y is more than 0. Now for these 2 graphs, that will be the domain and the range. We don't have an inverse graph then here. Right, thank you, grade 12.
With us on #LearnOn1. Tell us what you're learning and where you're learning it from. Send us your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
With over 300 games in 6 weeks, get DSTV to watch the best live football action.
We always love to hear from you. Send us your views, comments, and videos with your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
busy with logarithms. We're looking at those exponential graphs. And then today we're going to do it a little bit more algebraically. So if we look at this one, the population is equal to 2 to the power of t. So this is your growth factor. So if I ask now what is the population after 2.5 days, then it just becomes 2.5. If t is 2.5, then I can just substitute it in there. And my answer here is 5.66. So after 2.5 days, that will be the population. Now, what about 3.6? So 2 to the power of 3.6. And now you will see 12.1. Can you see it grows rapidly? It grows very rapidly. This is million. The coronavirus or a bacteria or malaria. But let's take the coronavirus. So this was after 2.5 days. After 3.6 days, just look at the growth, how much it has grown. Now, sometimes they ask you then, when will it be 20 million? So now we say 2 to the power of t is equal to 20. After how many days will the population be 20 million? So this we're going to solve with logs again. We're just going to use those logs. So what did we do? We said we log both sides. So it's log 2t is equal to log 20. You can see we're using that same method. Bring down the power. So t log 2 is equal to log 20. And to get the value of t now, we're going to say that t is equal to log 20 divided by log 2. Log 20 divide by log 2. And if you do this sum, I got 4.32 days. So after 4.32 days, it's going to be 20 million. That's how it will grow. And we keep on saying this is why it grows so rapidly, because it's exponential graphs that we have now here. Sometimes we also get that it looks like this. The population is equal to 5 to t. Now again, we must understand that this is my initial value. So that was the initial number of people who had the coronavirus. And this is my growth factor. That is your growth factor with how much it is growing. This is time then that we have there. On page 88, you will see there's also graphs. Then they're explaining more about growth factor. Now remember, we can also get a growth factor in the bank when we work with money, with compound interest. Then there's also a growth factor which would be 1 point something. Let's say it grows with 7%, then the growth factor would be 1.07. 100% plus that 7%. That is then your growth factor that we have there. Now I want us to look at exercise 23. Exercise 23 on page 92. On page 92. And this is now all about this growth factor that we have here. A colony of bacteria, let's say the coronavirus, has an hourly growth factor of 6. Initially, there are 400 bacteria. So how would we write this one out now? This is the initial, so the population is, initial value is 400, the growth factor is 6, and there is the time. So the question is now, after 10 hours, what will the population be? So then I'm just going to substitute the 10 in the time. But now remember, it's power first, then multiply. You cannot multiply those two. power first, then multiply. And my answer that I got out there, it's a very big number, 2.4 times 10 to the power of 10. I give it in standard form, but it doesn't matter. You can write it normally as well then there. Then they say, when will there be 1 million coronaviruses? So we have to equate the population now to 1 million is equal to 406T. Now again, power first, then multiply. So we have to get rid of this initial value right at the beginning before you can continue going on there. So 6 to the power of T is then equal to, and 4 will divide into this one, 2 times 25, 0, 0. We cancel those 2, 2, 5, 0, 0. That's right. To get T now, this is where we work now with logs. So it is log 2,500 divided by log 6. And that's how you will find T. Over how many days or hours do we have 1 million coronaviruses? So my answer is, the time is then, 4.37. 4.37. Okay, number 2. Let's look at this. Right, so we're continuing now with number 2. A decaying radioactive element, bismuth, was observed every few days. So estimate the growth factor. So we first need to find a growth factor there, and you will get that by dividing day 3 by day 2, day 6, day 7 divide by 6, and there we will find a growth factor. So if you divide that, we get 0.87. I rounded it off now. It differs a little bit, and then we must take the one in the middle there. Usually in your case, they will provide you with a growth factor. Now they say, write an equation giving the mass of the bismuth remaining in terms of T, the number of days from the start of the experiment. Now, if you look in the table, you can see originally there was 10, because 0 days gives you 10. Then we have the growth factor of 8.7, and this is to the power of time, days, in days. So that's your formula there. Number C, how much bismuth will remain after 3 weeks? Now this was in days, so I will substitute the 3 weeks with 21 days. Remember, power first, then multiply. So the mass over 21 days, remember this one is decaying, is then 0.547 grams. Then number D, after how many days will only half of the original amount of bismuth remain? Now originally it was 10, this is your original initial amount, so that means it's 5 is equal to 0.87 to the power of T. How do we solve this? We use logs, so T is equal to log 5 divided by log 0.87, by log 0.87. And time is then, and I have 4.977, which rounds off then to 5 days. Time is after 5 days. Now we have question, that was D. Question 3. In 1984, the population of North America was 247 million, with an increase of 0.7% per year. Assuming that this growth rate remains, write down an equation and find out how long would it take. So to reach 300, so we equate it to 300. It's 300 million, both is million. That's why I'm leaving the millions out. Initially, it was 247 million. Look at the growth factor. It's it's a growth, it's 100% plus that 7%, so that's why it's 1.07 to the power of t. You want to find the time, so we are going to divide with this value first, this initial value. You divide with that one first, then I'm going to use logs, so it's log, first dividing there, divide by log 1.07, and then my time is, and I got 28 years. It will take 28 years to do that. Now, we can do exactly the same with E and Lin. You can use now exactly those same methods with E and Lin. If you look on page 93, we have this population. It's mud crabs, 800 E 0.11 T. What is 800? My initial value. The number of mud crabs on the island of St. Lucia was found in the study, where population, P is population and T is the time. How many mud crabs were there on this island when the study began? And that is 800. That is my initial value. Calculated after 2 years. So now we're just going to substitute a 2 in times place, and after 2 years I got 996.86. The population grow up to there. Then how long will it take the population of mud crabs to double? Now, to double means it must be 1,600 is equal to 800 E 0.11 T. Again, I divide with this initial value. Then you have E 0.11 T. It works exactly the same as we did now. To get rid of E, we will say 0.11 T is equal to ln 2. And then finally, time is equal to ln 2 divided by 0.11. And if you press your calculator there, I got time is 6.3. That's just an example now where we work with E and ln. It works exactly the same. So now I want us to look at exercise 24 on page 95. Exercise 24 on page 95. So it's still about this growth factor. The mass of sample of radioactive lead is measured at intervals. The mass remains, and the formula is M is equal to 2E negative 0.2 T. So again, what will be the initial value? 2. And we're working now here with E. Find the mass left after 12 hours. So you will just substitute the 12 in there. Press your calculator. Don't forget about that negative. We need that negative. It will play a role. And my answer is then T is, no, it is 0, sorry, it's not T, it is M. And the answer is 0.181. Number B. Find the time it takes for the mass to fall 1/8 of the initial value. So this is my initial value. What is 1/8 of 2? And that is a quarter. So now the mass is then 0.25. That quarter is equal to 2E negative 0.2 T. How will I find T now? I will have to first divide by the 2. So it will be 0.25 divided by that initial value, negative 0.2 T. And then we're going to log both sides, but because it is E, we're going to ln now here. So it will be negative 0.2 T is equal to ln 0.25 over 2. And then to find T, it's then ln this value, divide by negative 0.2, and my final answer is, I got 10.4. 10.4. Right, the next one is question 2. Since the beginning of 1965, the population has increased. There's 1,000 E 0.02 T. What is the meaning of this 1,000? This is my initial value, the initial number of people staying on the island. And then they say, what was the population in 1965? So from that was 1,000, because that is my initial value. And then they say in 1980, now from 1965 to 1980, there's 15 years that has developed there. So now we calculate it. Remember, power first, then multiply. So you just press your calculator there, and I got 1350. And then in what year will it be twice? So it was initially 2000. Double or twice is then 2000 E 0.02 T. To get rid of the E, we ln, so it's 0.02 T is equal to ln 2000. And to find T, it will be ln 2000 divide by 0.02. And then we find that T is equal to 34.66. So it will take about 35 years for the amount to double, the population to double. Thank you, grade 12.
Namibia is known for its beautiful wide open landscapes. However, these deserted spaces also pose numerous educational challenges in our country's rural areas. Because of this, many learners are denied access to proper teaching and learning. At EduVision, we believe that education is the starting point to a journey of endless possibilities. It is EduVision's goal to prepare and guide learners in order to make the modern world they are living in accessible to all.
Prevention is important. Help prevent the spread of illness and keep yourself and others well. Hand washing is one of the most effective ways of preventing the spread of germs. Wash your hands regularly with soap and hot water, scrubbing your hands thoroughly for at least 20 seconds. Hand sanitizers can be used but are not recommended as a substitute for hand washing. Use sanitizers in addition to hand washing or in a situation where soap and water are not available. To avoid spreading germs, limit sharing of personal items such as utensils, cups, and dishes. Your skin acts as a barrier to germs, but your eyes, nose, and mouth are more vulnerable. Wash your hands thoroughly before touching your face, eating, or drinking. Avoid physical contact with others, including handshakes, fist bumps, high fives, hugs, and kisses. Social distancing is deliberately increasing the physical space between people to avoid spreading germs. While regulations may vary by country or area, The best guideline for social distancing is to maintain a distance of 6 feet from others. Germs can travel through the air from one person to another. If you sneeze or cough, do so into a tissue or the inside of your elbow to prevent the spread of germs. Avoid contact with ill individuals and insist they isolate themselves until they have recovered and are symptom-free. Clean and sanitize frequently touched common surfaces and high-traffic areas in your home and workplace several times a day. Share these guidelines with others and help prevent the spread of illness and maintain a healthy environment. An ounce of prevention is worth a ton of cure.
Game's about to start, but you're stuck here. We've got an app for that. Missing your favorite show because the fridge is running low? We've got an app for that. Stuck watching what she wants to watch? We've got an app for that. Waiting for the bus? App for that. Working late? App for that. And if the power goes out, we've got an app for that too.
All for you.
The DSTV Now app is the entertainment solution for anything life can throw at you. Simply download the app from your app store and add your DSTV account information to activate the app and start watching. Whenever, wherever you have a charged device and an internet connection, you have DSTV Now.